Hello. This short lesson will be about navigation, or finding our way at sea. We should all know about GPS, the global positioning system using satellites for navigation. A few of us might even know about the LORAN system, which used radio signals for navigation. But this short lesson deals with an older form of navigation that was used to explore the world for the 200 years before the 20th century. This tool is a sextant, first developed primarily by John Hadley of England in about 1760. It requires a clear sky and uses celestial bodies, the sun, moon, and selected stars, but it's easiest to use the sun, and that's what I'll show you roughly how to do that in this lesson. First, there are a few terms to know. Each sextant reading finds one line of position, or LOP. So each reading is shooting a line. For example, today we'll shoot a sun line. Or last night I could have shot Polaris, Deneb, and Arcturus if I was shooting star LOPs. Next, one LOP tells approximately where you are on the chart along a line. Two LOPs tells you that you are someplace close to where those two LOPs cross. And three LOPs tell you exactly you are in the triangle formed by where the three LOPs come together. Finally, what the sextant measures is the angle of a celestial body to the horizon from the spot the sextant is used. In our case, it will be the sun, so the angle from the sun to us to the horizon. So let's go shoot a sun line, or at least there are many other things to know about using a sextant for navigation. A few will be mentioned as we move along. Most will be left for later training when you're actually learning to use the sextant. First, here, this is a sextant. Also, we need a watch set with the correct time. With the sextant, we aim it at the sun, which is why there are these dark lenses. The optical that we look through is split in half. Mirrors are used to keep the sextant on the body being shot, the body we see at first, and then and as we pull that image down to the horizon to find the horizon, we look through the other half of the lens. So starting at an angle of 0 degrees, we see the sun through both halves, and the dark lens are needed. However, as the angle is widened to bring the sun down to the horizon, the sun stays behind the dark lens, so we can look freely out the other side of the optical. Using a sextant, we keep widening the angle until eventually we get the sun's reflection down to the horizon. In working with someone, when the lower edge of the sun is exactly on the horizon, I would say mark, and the helper would record the time exactly to the second. If alone, I would quickly look down at my pre-calibrated watch and record the time myself. In either case, I would then look at the sextant and record the angle for the sun, again down to the second. Around here, when I shot this, it's about 64 degrees and 38 seconds or so. With the angle and time, along with the nautical almanac, it is possible to find the sun line for that angle in that location, 1 LOP. If the sun line is shot with the sun at zenith, the highest point that day, or local point at noon, that LOP will be your exact latitude, or your distance above or below the equator. Without one line of position using a sextant, 2 more LOPs are needed for an exact position. In about 20 minutes, the sun will move along for another LOP to be effective. If course and speed are constant, it is easy to advance 2 earlier LOPs in an hour. Find out exactly where your location is. That is where you are, even with water everywhere and not a drop to drink. Thank you.